Greetings, Tezos Nation. Welcome to another edition of TezTalks Live. I'm Stu from the Tezos Commons. Joining me today are software engineer Thomas Latan and engineering manager Yann and both from Nomadic Labs. Nomadic Labs, for those who might not know, is one of the largest research and development centers in the Tezos ecosystem. It's composed of more than 50 engineering researchers working on the ongoing development and adoption of the Tezos protocol. The team also focuses on business development in France, Belgium, Netherlands, and Luxembourg. On today's stream, we'll be giving away a Tezos branded Nano Ledger to one of our lucky viewers. If you'd like that lucky viewer to be you, keep an ear out for a keyword later on during the stream. And of course, if you have any questions for Thomas or Yann that you'd like me to ask, please add them in the chat at any time. We'll get to as many as we can before we wrap up. Hi, Thomas and Yann. Where are each of you, and how is the weather?
Hello. Thomas, do you want to answer this one?
So, we're both in Paris, and in Paris, the weather is mixed, but currently sunny. So this is a win.
That's great. Yann, we already delved a bit into your backstory during your last appearance on TezTalks Live, but Thomas, seeing as this is your TezTalks debut, can we start off with you walking us through your professional background and your personal journey down the Tezos rabbit hole?
Yeah, with pleasure. So I've been doing a PhD 10 years ago now. Time flies a bit. Which was concluded in 2018 with a focus on low-level hardware security. And so it was a bit far from Nomadic Labs and Tezos. But yeah, I've started to work on Nomadics 2 years later, a bit more than 2 years later, in early 2021, and since August 2021, basically, I'm working on optimistic rollups, there. So it's been an interesting journey from the first project up to the smart rollups unveiling, I would say, in March of this year.
Cool. And for the sake of those who might not be familiar with Nomadic Labs just yet, how do you describe it to people who ask you?
I mean, you already did that pretty well, I would say. Yeah, we really have these two jobs, I would say, or two main missions: to take part in the development of the Tezos protocol with the R&D department, and to foster the adoption of Tezos in as you mentioned, like France and Belgium and Netherlands and Luxembourg,
AKA Benelux, as I've just learned.
Exactly. Yeah.
That's great. And Yann, from your perspective, what exactly is Nomadic Labs' place within the Tezos ecosystem?
Well, I think Nomadic Labs has both still a central place in the core development, for sure, for the simple reason that even so we have a very tight collaborations with 3D Tech, MyGoals, Foundry, and other companies that participate in what we call the core dev initiative to help developing the Tezos protocol. So we have this central place because we have a lot of engineers, actually, and very good one, and we are contributing to all aspects of Tezos, I think. We do have these active places, but also historical places, because a lot of the very first developers of Tezos are still engineers of Nomadic Labs. So a lot of legacy code is their legacy. They have to assume to take responsibility for this, but also, of course, the expertise that they accumulated for 5 years is valuable and important. So, yeah.
Okay.
It is also important to mention that Nomadic Labs has a very strong activity in terms of adoption in the Benelux, as you said. And it's something that is important because, for Tezos, it's important to have more and more use cases and institutions and companies interested in using this very nice technology.
Absolutely. And as you mentioned, there's obviously a lot that the Nomadic Labs team has been involved in here in the Tezos ecosystem, and certainly a lot more currently in the works. But the reason we've invited you both to TezTalks Live today is to talk about something we've all been hearing a lot about lately, and that's Rollups. We've seen a few very interesting presentations in the Tezos space recently and beyond that involve rollups in significant ways. We had the 1 million TPS demonstration at TezDev 2023. And Thomas, I understand you personally presented the Tezos EVM rollup at ETHCC just a few short weeks ago. And Tezos co-founder Arthur Brightman also did a presentation on ultra high throughput, Tezos 2.0, and the important role rollups are expected to play in both of those projects moving forward. I would like to touch on all three of those topics with you today.
Yeah.
Cool.
Before we get into all that, can one of you give the audience a simple explanation of exactly what a rollup is?
Do we play this one at Shifumi, Thomas?
Right.
We are really used to explain rollups, so I think, yes, Thomas, please.
Okay, I can do that. So typically, the core idea of layer 2s in general is so there are several approaches, but let's say that the one aspect that we focused on quite early was the scaling story, like to allow Tezos to scale as the use of Tezos would grow in the future. And there were various ways to do that, and initially a lot of effort has been spent, typically in 2021, in improving the layer 1 itself. So what we call Tezos today, which is like the smart contract infrastructure, and we have on the call one of the engineer responsible from rewriting the Michelson interpreter in 2021. So there have been a lot of effort in that direction, but at the end of the day, there are a significant challenge in scaling a layer 1 network, in the sense that you want to be able to execute as many transactions as you wish for, but in the same time you still want to keep the network open and as decentralized as possible, so with the lowest bar of entry. And so one of the ideas of optimistic rollup in particular is to try to fix that challenge by letting the layer 1 focusing on consensus and typically on giving an order to operation that you want to execute, but by offloading the execution of this operation in dedicated pod of execution, if we can call that like that. Typically, rollups would be this pod. And so optimistic rollup in particular are a way to achieve that. There are other approaches, but we've been focusing on optimistic rollups. The key idea of optimistic rollup is that you offload the computation and you have the node that computes the state of your rollups regularly post the result of this execution, and as often in the blockchain workspace, like this result of execution is the hash of the state, basically. And so you regularly post the hash of the state, but of course, because you only post the hash, you cannot trust it by default. And so in addition to that, you have to implement a way to keep the rollup in check and to be sure that what is advertised as the state of the rollup is correct. And what is done with that is what the Ethereum ecosystem is calling like interactive fraud proof. that we tend to call refutation games because it's ticked. we started to call that, but it's basically a protocol that you can have with like if you have two parties that disagree on the state, they post a different hash, and then there is a protocol for them to resolve this conflict and to prove to the layer one who is right and who is wrong. And this is this thing is potentially one of the hardest part of the optimistic rollup framework, because you need to be sure that proving to the L1 doesn't imply pushing too much data and too much computation to the L1, because what you want to avoid is that you want to the footprint of the rollup to be as minimal as possible. And this is basically the challenges, but what you get is a way to offload computation very efficiently. And so you can have layer one that remains fully decentralized, that decides the order of the operation. And then you can have very powerful machines that run the operation. And that remains in check, policed by other third parties, because at least for what we did on Tezos is to keep this fully permissionless and fully decentralized.
Okay. Is there a particular practical application, like a particular use case that you think illustrates what a smart rollup is good for?
Maybe just can I continue, Yann?
Oh, sorry. Sorry.
No.
Take over if you want.
Let's go.
Yeah. So, what are the use cases for rollups? Well, as Thomas said, the main point of rollups is to offload computations so that you can actually treat these specific problems in a dedicated way with the ability to actually use infrastructure that is of the right dimension that is really dedicated to a given application. So why you want to do that? Actually, it can be about scaling. But scaling it's related to cost. Actually, if you have a system that has some capacity, a limited one, people will have to pay more to use it. If you have a system that has a large capacity, the cost will be smaller. So the use cases of rollups are directed in some way, from my perspective, to the idea of optimizing the cost. So today, when you have a DApp and you run it on the layer one of Tezos, since the system currently is not congested, the fees are quite not that much. Okay, so it's okay. But imagine that at some point you need your DApp is working well and you have a lot of activity. Then you want you will still have some important fees to pay. Mm-hmm. So you may be looking for another way to reduce this cost, and this way can be just offloading your operation to rollups. Okay, so and here you have again two paths. Either you are you find someone that will provide you an infrastructure that is less costly. So more or less it will replicate the notion of chain, but on a layer 2. So you will be able to redeploy your DApp on an infrastructure that is not handled by yourself, but that is providing better lower cost. Okay, so that's the first use case. So replicating the notion of L2 chain. So for instance, you can have Tezos on top of Tezos or EVM on top of Tezos, etc. And you have another cases where actually your app is really, really successful. And in this case, you need really 1000 TPS only for your DApp. In that case, you are more in the app chain use case category, in which you actually want to provide your own infrastructure so that you don't have any fees to pay except the basic one that you have to pay to publish your commitments to layer one, but they are more or less 30 euros per year today, so it's quite okay. But then, since you are coming with your own server, it will be more efficient from a cost perspective because you are in control. There is no intermediate people. Okay, so that's the three use cases today to deploy the app. And as you can see, Rollups just provided the last two.
All right.
Yeah, and just to jump in to make a quick precision, one thing that is important to understand and potentially difficult to explain clearly is that what smart rollups are actually I would say an infrastructure, a public good to implement optimistic rollup on Tezos. So if you take the example of the Ethereum ecosystem, for instance, you have several optimistic rollup technology. I guess the two main ones would be Optimism and Arbitrum. And what they have to do is to re-implement the overall infrastructure that I've quickly described about publishing states, gathering operations, having these fraud proofs that they have in a closed on various various states, I would say. But eventually they have to re-implement the optimistic rollup infrastructure for their personal use case. What smart rollups are really a way to implement an optimistic rollup where all the plumbering, I would say, or all this integration with the layer one, all this interaction fraud proof, are implemented for you by the Tezos core developers and are provided notably by the Tezos protocol, but also by tooling that we are providing, and that you get for free in the sense that it's open source and it's public on a public chain. And this is really I would say something that so I don't know if it's to which extent it set us apart at the beginning. Like in March, I would say that we were probably the solutions that from this perspective of providing an infrastructure for you was really convincing. I think that Optimism is also pursuing a similar strategy to try to be like a framework for optimistic rollups. But yeah, I would say that this is something to keep in mind, is that you get an infrastructure, a public good to some extent. And so it's similar to smart contracts, like smart contracts on Tezos allows to implement decentralized application with certain trade-off. And smart rollups are that. And in particular, it can address a lot more use cases, but potentially with different trade-off. And typically, you get infrastructure cost because you need to provide your server to execute your particular node, which is can be interesting. But if you are a very low activity app because you just need to do some notarization, for instance, maybe you don't need a full brand new layer 2 for your use case. But maybe you are, for instance, you do logistic and you can have a very large volume of data to handle periodically, and you don't want to pay fees on a layer 1 to handle them. Then using a layer 2, either on an app chain or a generalized one, can be very interesting.
Okay. We have one audience queue that I'd like to bring forward at this point. Ryan would like to know, what do you think will be the killer app for smart rollups?
It's a wide question.
Of course.
And so we know what killer app we are working on. I don't know if it's a killer app, but at least it's products that we think can make a significant difference in that is EVM rollup. And then I guess what will be a killer app is probably an application, like a decentralized application that really demonstrate that explodes in popularity but most certainly not because it's a smart rollup. I mean, like smart rollup are not an end by itself, it's a mean. But the day we have a decentralized application that couldn't fit in the layer 1 and happen to have been implemented in a smart rollups because they were because of reasons, and we can imagine several, like anticipating the use or thing like that. Then we get a demonstrator of what you get with the smart rollups.
Okay. And Valentina would like to know, what's the difference between a data availability layer and a smart rollup?
So data availability layer is completely different things actually. It's a component of the system that takes as a responsibility the fact to provide data, to make available data, so that the blockchain can process it. Maybe I should just roll back a little bit on another story. That is not the scaling story, but the modularity story to explain smart rollups and data availability, and maybe Tezos 2.0 too. So maybe it's a good time to talk about this. So what the industry is doing is starting to understand more or less is that actually when you need to develop a blockchain, so these ledgers that provide decentralized access to a trustless computational platform, okay, so this complex problem actually it can be decomposed. And that's very important, because when you decompose a complex problem, you are able to tackle it in a more efficient way, because you can consider each problem separately, find efficient solution for each problem, perhaps in a better way, because you can focus on this problem, and then you join the solution and you get back a solution for the overall problem. Okay, and what we are understanding these days is that blockchains actually can be decomposed in 3 sub-problems. First one is to decide what is the truth with a consensus, so that decentralization is respected. Okay, that's very important that's why blockchain are. It's about, for instance, preventing censorship, making sure that a consensus is reached. Second problem is what are actually the data that you want to put as an input to the system, okay? How to retrieve them, how to make them available to everybody, so that someone can reconstruct, redo, check the system. And third, how you compute actually. Well, what are the rules that you need to apply to compute, okay? So first problem is solved by the layer 1 consensus. Second problem is solved by data availability solution, the DAL and the DAC. We will come back on this. And the third problem is solved by rollups, okay, in our case. Okay. So data availability is really about a solution to provide data. And then you have two different flavors today. We have the DAC approach, that is a purely external solution that says, based on some trust I have in a committee, that we sign certificates about the availability of data, I will accept to consider this data available and accept it as an input for my system. Because that's the DAC. It's simple to implement, but it's less. I mean, you extend your trust. You don't only trust the layer 1, you also trust this committee. Okay, so that's the trade-off. But it's simple to implement and very efficient. And the other way is DAL, the data availability layer, and that's included in the trust is now based on really on the layer 1. So it's a way to reuse the consensus and the trust that you have in the bakers, typically, to put on them the responsibility to say and to say that, to assess that the data is available by some ways. Okay, and that's far more difficult. It's still an open problem for the industry actually to implement this. And we have made very good progress on this topic recently. We have a DAL that is reaching testnet, sorry, and yeah, that's sorry, it's a very long answer to a short question, but it's more or less another technology that we are currently developing and that is reaching public.
Okay.
Now.
Okay. Now, Thomas, as I mentioned, you presented the Tezos EVM rollup to the crowd at ETHCC in July, which I understand has been dubbed Etherlink. Can you talk a little bit about Etherlink and why this particular rollup is a significant one for the Tezos ecosystem moving forward?
Yeah, and it's perfect because it will also be the opportunity to answer one of the questions of the chat. So, so typically asking about the differences between like smart rollups, Etherlink, potentially EVM, and ultra high throughput. So just starting from that and going to your question also. So you have to, as I mentioned, like smart rollups are a framework to some extent, and that allows you to build optimistic rollups. And the first optimistic rollup that we wanted, like one of the optimistic rollups that we wanted to implement very quickly was what we called internally an EVM rollup. And an EVM rollup, basically, it's a rollup in which you mimic an EVM compatible blockchain. It's a bit as Yann mentioned, like you can use smart rollup to implement blockchain-like system where you have the same notion of blocks and the same notion of fees in the L2 and things like that. And what it gives you is potentially an execution environment that will be more efficient and cheaper than the layer one, but still enjoying the decentralization and the consensus of a layer one, so not having to implement that and just focusing on the execution of the operation. And so one of the things that we wanted to do is to use the EVM compatibility to Tezos. It's been a long topic because there is, I think we still don't regret the choice to have our own smart contract language on Tezos, and in particular, Michelson has a lot of good properties that I think we still don't regret, and we still stand true to them. But in the same time, it would be a lie to say that it hasn't been a challenge to market or to push Michelson, when at least today and for now, in the Web3 industry, EVM is seen as almost as a standard, or maybe not as a standard, but the pool of developers in the Web3 is really focusing on EVM. So the Tezos layer one, we still don't think EVM is a good fit. But now with smart rollups, we have a way to bring EVM compatibility without sacrificing the good properties of Michelson. And what we wanted to do basically is to implement something very similar to what the Ethereum crowd call generalized layer 2s, and typically what Arbitrum is or Optimism is, where you have this blockchain, not fake, but like optimistic rollup blockchain, I would say. And in the EVM rollup, the smart contract language would be EVM, and the tooling around it, like indexers and stuff like that, would be compatible with the Ethereum ecosystem. And what we get from that is the Ethereum ecosystem. Like the EVM rollup has already an indexer, and it costs us zero engineering efforts. Because we just implemented the correct API, and then the block scout for the ones that we are using worked out of the box for us. Like so, it's a heavy gain, and so people that are using MetaMask, for instance, can use the EVM rollup also, and they can do that because we are implementing the API of the Ethereum ecosystem. And to try to conclude this question, because we are probably talking too much, but Etherlink is the EVM rollup that we want to deploy eventually on mainnet, and that we are considering as a public good. Similarly to this, it's a word that we are using maybe too much, but in the sense that it's something that is being developed by the core developers for the community, with a strong focus on decentralization and for Etherlink on cost efficiency. The idea being that it should be cheap to execute operation on Etherlink, the same way it's cheap to execute operation on Tezos. And we want to propose to the community to delegate the governance of this rollup. And by governance, typically what we mean is the new upgrades and the new features that we are bringing to the rollup. We want to delegate the governance to the bakers of the layer one. That has a good property to be a pretty good decentralized committee. And so typically what we want to do is that the upgrades of the Etherlink will be part of the upgrade of Tezos, or integrated to the upgrade of Tezos that we are proposing, and to let the community decide whether or not they agree to deploy it or not. Yeah.
So as you mentioned at this stage, this is still in GhostNet at this stage. You're looking to move it to mainnet at some time in the near future. In the meantime, how can the Tezos ecosystem support you in bringing Etherlink to fruition?
So I would say testing is always and feedback about the test are always welcome. It can be a bit challenging also because so we've published a blog post on the Nomadic Labs blog explaining how to try to test the EVM rollup instance that has been deployed on GhostNet. And if you happen to have a large, or I would say decentralized application implemented in Solidity that works on a Ethereum compatible or EVM compatible network, and if you have time, please try to deploy it on a rollup. See where it breaks. If it breaks, maybe it won't, and don't hesitate to provide feedback. This is also a bit of a double-edged sword to propose, in the sense that typically after HCC we had a lot of very enthusiastic early testers in a very short period of time, and it's sometimes a bit hard to keep track of all the questions and to be sure that everyone gets an answer. So sometimes we sometimes take a bit of time, but it's not that we don't care. It's probably that engineering life happen, and so a bit of patience is always welcome. But we really value, I would say, feedback. And in particular, today we have deployed the first upgrades of the EVM rollup on GhostNet. That fixes most of the bug. I say most as asterisk, to not say all, because, but let's say most of the bugs that have been reported have been fixed, and this has been deployed on GhostNet. And it's maybe a good opportunity to say that smart rollups, as Tezos itself, has been designed to evolve. We stay true to this, and the VM rollup in particular has already the infrastructure to have ambitious upgrades, and so this is pretty enthusiastic. We are pretty enthusiastic about that.
That's great. And you invite people to come and test and participate and give you feedback, and that's awesome. And this is all great stuff so far. I'm excited to dive a bit into UHT and Tezos 2.0 as well, which you've both mentioned a couple of times. But before we get into all of that, are you ready for a special 2-guest edition of the world famous TezTalks Lightning Round?
Why not?
Just before we do that, I'll announce the keyword for the Tezos branded Nano Ledger we're giving away today. Today's keyword is !Etherlink. Enter the keyword !Etherlink in the live stream chat, and Nightbot will randomly select today's winner, who we'll announce before the end of the stream. Okay, now Thomas and Yann, it's lightning round time. Remember, there are no wrong answers, and this is just for fun, so our viewers can get to know you a little bit better. For each question, you can each provide an answer, and I'll tell you whose answer I like better. Are you ready?
Yes.
The best cuisine in the world comes from which country?
France.
A lot of them. I wanted to say France too, but in
no. It's Fact, just it's not. Don't worry. It's
Apparently, the word stick it's in Italy. So
Lightning round, gentlemen. Lightning round.
sorry.
One word. The best movie ever made is.
It's too hard.
Matrix.
Okay. Excellent answer. Thomas?
Lord of the Rings.
Both great answers. I'm going to give this one to Thomas. What's the perfect thing to do on a rainy day?
Coding.
So for the next few weeks, Baldur's Gate 3.
On a scale of 1 to 10, how likely are you to write code on your day off?
5.
11.
11. Okay. I'm going to give this one to Yann. And number 5, what is the meaning of life?
42.
Love.
Love. I'm going to call that one a tie. Thank you. Those were excellent answers, and you're both winners for participating. This concludes the TezTalks lightning round. Let's get back into it. I'd like to go a little further down the Tezos futurist rabbit hole a bit and talk about ultra high throughput and Tezos 2.0. As I mentioned off the top, Arthur recently presented a bold vision for the future of Tezos at TezDev 2023. Were both of you in attendance at that?
Yes.
Okay,
Yes.
Great. So start off with Yann. In broad strokes, what is ultra high throughput as you understand it?
Yeah. So it's very simple, actually. We believed for a long time that rollups were about horizontal scaling, so the ability that can add more infrastructure to the system to make it able to handle more throughput. But actually, since you are in control of the infrastructure and you can choose a very beefy, strong, large, powerful machine, you can also scale vertically, which means that you can have in one single execution framework, like a rollup, a very fast throughput. Okay, so if you take, let's say, a 128 core machine, and you are able to parallelize to use these cores, of course, then actually you can also have a lot of computational power in a single rollup. So that's the main idea of ultra high throughput. So yeah, why would you want to have that? If you're able to reach 1 million TPS in Tezos using horizontal scaling, why do you care of having 1 million TPS in one rollup? Why is that important? Well, it's because there is a weakness in smart rollups that we already described many times, probably. It's the latency when you have to have something go out of the smart rollup. You need to wait 2 weeks to be sure that you are allowed to have something out. And that's a difficulty when you want to have things move around between rollups or rollups and layer one. And one reason to have everything 1 million TPS in a rollup is that actually for most of the D apps that you need, actually 1 million TPS is far enough. So you could just recreate a chain. You remember the first use case that we discussed earlier in a single rollup for most of the use cases. I mean, can imagine, for instance, taking all the D apps that are currently running in the layer one, take Etherlink activity, take what you want. 1 million TPS will be enough for all this common good public infrastructure. And yeah, so that's the big idea of UHT. And there is another one. The other one is that actually, if you want to do that, you want a form of universal machine in some sense. So the ability to take anything, you have such a strong computational infrastructure that you want to be able to execute, to make it open to the wider public as possible in terms of developer. You want to be able to run Python, JVM, what you want inside this very large machine. And so another goal of the Ultra Throughput Tezos 2.0 project is to actually work on the interoperability, on the openness of the system with respect to the development tools that you use. So typically today, you can use all language that target WADM, but actually there are some subtleties that make it not that easy to not use Rust. Rust is fine, we provide very good support for this, and if you are okay with Rust, it's perfect. But now imagine you have a JVM or Python code, it's not that easy to actually run in WADM. It's perhaps feasible, but not perfect. And so we want to take the opportunity of Tezos 2.0 to do an iteration on this problem and even improve a bit more the interoperability of this single very large rollup.
Okay.
Does that make sense? Yeah.
Yeah. So the ultra high throughput rollup is a single rollup where a lot of these computations can be offloaded to, thereby relieving some of the pressure on the L1. And then we, as part of the larger puzzle, we're also looking, as you say, at interop and people being able to build in this space with all the different languages that they're familiar with. So was that sort of larger Tezos 2.0 vision that you're talking about, was that developed in an effort to solve existing problems within this ecosystem, or was it more with an eye toward anticipating the needs and opening new use cases for the future?
You answered the questions, the second part of your questions. Yeah, so here we are really talking about the next generation, okay? And we want to not block ourselves in a corner. So to be able to implement this vision in, let's say, I don't know, 18 months to have, I'm saying random numbers here, but the idea, in 18 months, we want to demonstrate that we are able to do it. In 3 years, to have it in production, something like that. So we are long-term from a blockchain industrial perspective. It's 3 years, it's infinity. So we are really here preparing the next generation already, so that the current generation, the one that we described in the first part of this presentation, smart rollups in WASM, etc., can be used today, so that we have a path that is already clear to prepare the future of Tezos 2.0 in, let's say, 3 years in production. Okay, so that the same idea that when Intel is selling you some CPU, actually in their labs they have the next generation already testing. But we want to be as transparent as possible to explain that we are already working, designing this system, so that and we are continuing, and we are putting a lot of effort to make the current system very usable, and so that you can invest in this and be sure that you will have a migration part to the even better next generation that we are preparing.
So those who might be right now, as we speak, building on sort of first gen Tezos rollups can expect that that's going to be migrated over to whatever the Tezos 2.0, whenever that becomes a reality. Yeah.
Yes, exactly.
Okay. So with EVM, which we've talked about, EVM rollups, and with this sort of Tezos 2.0 vision, increasing the interop, increasing the throughput, it sounds like you'll both be very busy for a while. Is there anything else that's in the works right now, or are those two things where you guys are going to be focusing?
I think maybe in addition to that, there is also the fact that what we built with the smart rollup is not a product per se, but really a platform that we want to be usable not only by us when we build the Etherlink, when we build the Tezos 2.0 stories that Arthur is starting to give, but we also want, as you suggested, other folks to be able to use it. And what that means is that at some point we need to spend significant effort in terms of providing the documentation, providing I would say like also courses, potentially examples, and exploring what we know will be use cases. So to give you an example, Yann mentioned that we are investing in Rust in particular to implement on smart rollups. And typically the Etherlink rollup is implemented in Rust. But one of the key components that we are building is what we call the Rust SDK, which is arguably a library or a framework that is implemented in Rust and that you can use and give you the basic building blocks that you would want to use. So we mentioned DAL, we mentioned DAC. You will have that they are very low level primitives that you on a day-to-day basis you don't want to use them directly. You want to have high level helpers that you can rely on. Typically, it's the same way that you like having buffered the library to interact with the file system and not directly the file system to improve performances. To just give an example on the top of your head, and so there is a balance to find because we don't want to spend too much time building a platform with no products, and in the same time we already have spent a significant amount of time on a platform that can solve real use cases. But it's like the 80-20% issue where we solve 80% of the problems, and now we have 20% of the work remaining that is actually taking a lot of time. So I would say that in addition to building Etherlink and building these two products, because they are more close to a product to some extent, we have still this platform level work to do.
Okay. So just to sort of wrap this up, what does the timeline look like for UHT and Tezos 2.0? Is this something we should expect to see rolled out in the near future, or will it be a sort of ongoing evolutive process? Like, is there a finish line here, or is this something that is just going to keep developing and evolving as we go, as Tezos has done historically?
Yeah, hopefully there is no finish line for Tezos, right?
No, and it would be really continuous as we are used to do in Tezos. One aspect that we did not say is that also the work on Tezos 2.0, so prototyping, designing, etc., will probably reveal low-hanging fruit that will be implementable very in the short term on smart rollups. So we have some in mind. I won't commit, but we have very good ideas to improve even the throughput of existing smart rollups, and also the interoperability, by the way. So it will be continuous,
Okay.
because that's the only way also to have good feedback from users. And again, we are looking for this feedback. Please join Slack. Say what you need to say about UX, DX, etc. We are looking for these inputs and to continuously improve, because we have this possibility to evolve continuously. So we use it.
Right on.
And to precise a bit, just a bit a concrete answer for Etherlink, the goal is that it's a product for this year. So of course there is also the asterisk and coming when it's ready, because it's important to know to delay if it brings value. But the goal really for Etherlink is to be something that you can use in production by the end of the year, and ideally
with an asterisk, as you said.
Yeah, exactly.
That's great. I have about a dozen questions that we weren't able to get to, but unfortunately we're at the end here. And before we close off, I need to announce the winner of the Tezos branded nano ledger we're giving away today. Today's winner is Joel McCann. Congratulations, Joel McCann. To claim your prize, just email us at social@tezoscommons.org. We'll request a screenshot for verification that you're the account owner, and then we'll get your shiny new ledger over to you just as quick as we can. For those who missed out today, we remind you there are awesome giveaways to be found frequently here on the TezTalks live stream, so keep tuning in. If you'd like to get in touch with us, our social media contacts can be found at tezoscommons.org/TezTalks, and we'd love to hear from you. Thomas and Yann, thanks so much for joining us today. It's always awesome to speak to the folks building and developing here in the Tezos ecosystem and keeping Tezos at the forefront of the Web3 revolution. Is there anything else you'd like to mention before we sign off here?
I personally, I'm a bit, I don't know if amazed is the correct word, but like impressed by the numbers of questions that we had, and I'm afraid we were a bit off with respect to answering all of them. So I don't know if we can get an excerpt. Maybe we might be able to produce a written answer or something like that. Could be a nice
follow-up. I mean, we'd love to have you on again sometime down the road, and maybe we can get to a few more of those audience questions when we do.
With pleasure.
Okay.
It's always a nice experience for me to participate in this kind of stuff.
To everyone out there in Tezos land, thanks for joining us on the TezTalks live stream. I'm Stu from the Tezos Commons, and our awesome guests have been Thomas Letan and Yann from Nomadic Labs. Now let's go pave the way to the future.
Thanks a lot.